Hello and welcome to the fifth video introduction to the 4051 and its basic language. In this video we'll talk about character strings, string variables, string functions, getting text and other input from the user, and formatting print output. There's a lot to cover, so it may be the longest video yet. Let's get started. Strings contain text, and we've already seen some examples of using character strings in previous videos. Any text inside quotes is a character string. If you print some text, you are using a string, like this. So the print statement will just print out whatever is in the quotation marks. If you need to have a quotation mark in your string, you can put a double quotation mark, two quotation marks in a row, to embed it inside the larger string. So there at the end we have the double embedded quote followed by the ending quote. If you want to store a string in a variable, you can do that so that you can test it or change it. This is done with string variables, and there's only 26 available on the 4051, one for each letter. To distinguish them from numeric variables, a $sign is used. Here's an example of setting a value into a string variable. There's the $sign to show that it's a string variable and not a numeric one. Now the variable has a value and you can print it out. And again, any variable, if you just type the name, it'll show the contents. Remember, this is technically a let statement, so you could say let a string equals some text, but almost no one ever does that. The let is optional. You can add or concatenate to the end of a string variable using the ampersand operator. Here we're adding the previous contents and we're adding more text to it. String variables can store up to 72 characters. Remember, these 4051s back in the day did not have a lot of memory, so things were pretty small. If you need a larger string variable, use the dim statement before setting a variable. So here's a little program that demonstrates this. So this is not 100 string variables like it would be for a numeric array. It's 100 characters in one string variable. Make a little for loop to add to the string 10 times. Let's run it. And there you can see the loop executed 10 times and added to the string, and it's now more than 72 characters long, but within the 100 that we allocated for it. Often when running a program, you want to ask the user for some information, or what's called input. Here's how to get some text from the user with an input statement. Notice the use of the semicolon to prevent the printing from going on to the next line. So I'll list that since I typed over one character. Let's give that a run. And there we go. Common usage of input statements is to ask a yes/no question in a program. For ease of processing the reply, sometimes it asks for a Y or N reply. Let's clear our program with del all or delete all. So this program, or part of a program, we'd have to add more to it, would go on to line 200 if the input was a Y. Otherwise it would go on to the next line, whatever that is. Let's add something real quick here. It's an N. If we type a Y, oop. If we type a Y, we'll get yes. If we type no, an N, we get no. There are a number of functions that operate on strings. Let's see how some of them work. First, let's set variable n string to have a value. First one, len, gives the length of a string variable. So we can see it has 3 characters. You can also just operate on a string that's not set into a string variable. You can find the segment, a segment of any length. You can find a segment of any length from a string variable or a string constant like we did there with the seg for segment function. List that so you can see it clearly. Oh, we still have a couple lines left from the previous program. You can get rid of them by just typing the line number. And there you can see it searched the A string value for the 12th character in it, and that was the 12th letter since it was the alphabet, and we got the L in response. Note that you must assign the result of a seg function into a string variable. It's just the way it works. You couldn't print the result directly without doing that first. You can also replace part of the contents of a string variable or a constant. Again, the result must be assigned into a string variable. So this is done with the REP for replace command. Here we'll correct the beginning of the alphabet. We'll start with the second character position in the string and replace 3 letters. So even though we have 3 letters, we could actually replace more or less than that. If you want to insert a string into a string without changing any of the contents, just adding to it, then that last parameter would be 0. So now we see the correct start of the alphabet. If you want to find a character or a string within a variable or constant, use the POS function. It returns the position within the string where the search is found, or 0 if it isn't found. Here we're going to look for the letter D, starting at the first position, and it finds it in the fourth position. If we tried to find it starting at the fifth position, we get 0 because we've already passed where it is. But if we look for A starting at the fifth position, it will find that last A, not the first one because we told it to start after it. You can convert a text string that holds what looks like a numeric value into a number with the val command. Here it takes the string and shows you the equivalent value. If the string contains non-numeric text, it finds the first number part. So that's sometimes good for processing user input. The format is the same as if the number were printed out using a print statement. As you can see, there's a leading space on integers, just like if we did this. If you take the value of something that doesn't have any numeric content, you get an invalid function argument error. The opposite of val is str, which converts a number into a string, so then you can assign it to a string variable, for example. Now if we print out a string, you get that value as a string. It can also evaluate numeric expressions. As you can see there. Finally, there are functions to convert a character to its ASCII code and back again. So if you want to find the ASCII value of a letter, use ASC, and to convert it the other way, you use CHR. Do 97. Let's try that again. There we get a lowercase a. Now let's look at how you can format printing using the print using statement. Often you want to control more accurately how your output looks to the screen, whether it's numbers or text or a combination, and you can do this using print using. Let's look at an example. Let's just delete any program we have and clear the screen. Type in a little program. First, we'll look at how a regular unformatted print statement works. We'll print out a value in a little loop, and it's square and cube. If we run that program, the columns don't line up. It's readable, but it's probably not what you want. So let's try it again, changing the middle line to print using. The format is given inside of quotes, and these show how long each of the output fields should be, and then at the end we have the values to print. If we run that again, let's list it first here. We just changed one of the lines of the program. Now everything's in nice fields. D is used to print one or more digits, and the number preceding it shows how many columns to reserve. If If you don't give enough space for the numbers being printed, an error occurs. So always make sure that you have enough. Let's try it with just one character. You can default without typing one. You can just say D. As soon as we get to something that has 2 digits, we get an overflow error. Strings can also be formatted. While numbers are right justified, so they line up like we just saw in columns, strings are left justified. And you use the A format. And there you can see the first one starts at the beginning on the first column, and then using up 10 spaces we get to the 11th column for the second string. Anytime you have a repeating format like that where you have the same thing twice in a row, you can do a shortcut. Same thing, but we've saved a little bit of typing. If you end up using the same format a lot, you can put the format in an image statement and then refer to it by the line number of the image statement. Let's clear out our program, type in an example. So there's just the format without quotes. If we run that, we've used the same format twice. Note again that the quotes are not needed on the image statement. There's a number of other formatting capabilities in print using. You can use E for exponent format. Be a 3. The number before the E controls the number of significant digits. There's also L for line feeds, P for page clearing, T for tab, / for carriage return, and X for space. The T needs a number to indicate what column to move to, so it's not like a normal tab character that moves to a predefined column. Let's look at an example. So these second and third numbers will print starting at the 4th and 12th columns. I didn't have the last D. You can use the reprint function key to see what you have if you've typed over it a number of times. That's the problem with a storage tube like the 4051 has. There we go. The X for spaces can do the equivalent thing. That reprint again and fix it. So the equivalent of what we just did would be that. Note that the commas in format strings for print using are for readability only, and they're not required. So you could do this. And it would be the same thing. Finally, the D format has a number of modifiers. Some of the most useful are F, which specifies a print field large enough for the number being printed, and C to add commas for large numbers. These can be combined like this. And there you get a field that's large enough for the number, including the comma that it prints. There are a number of other formatting options for print using. For full details, see the image statement section of the 4050 series graphic system reference manual, which is available on the BitSavers website.